Hello, class. I just want to go over a homework problem. This is Math 1430, homework problem from section 3.6. Let me get the whole board in here in case you want to hit pause and write any of this down. So here's what the question says. Find the equation of the tangent line to the graph of this equation, x minus y minus 1 all cubed equals x at the point 1, negative 1. Notice 1, negative 1 solves that equation. When x is 1 and y is negative 1, it solves the equation, so that's why it's a point on the graph. Okay, so let me zoom in here a little bit. So Math 1430, and we want to find the equation of the tangent line. So whenever you want to find an equation of any line, you always need a point and a slope. The point is given. X is 1, y is negative 1. Remember, all points are x comma y. So now we have to find the slope, because once we have the point and the slope, then we can find the equation of the line. Because this is a tangent line, the slope will be given by the derivative. Derivatives give you slopes of tangent lines. And notice this equation. It looks darn hard to solve this equation for y. So to find the derivative, we're going to use implicit differentiation. And the left-hand side is going to require the chain rule. Okay, so for the solution, here's what I wrote. We need a point and a slope to write an equation of any line, but we're looking for a tangent line. So same thing, tangent line is a line. We need a point and a slope. So the point is given at 1, negative 1. So remember, ordered pair that is. X is 1, y is negative 1. To find the slope of a tangent line, we need a derivative. We must use implicit differentiation, since the equation is not easily solved for y. So here goes. I'm going to flip the camera sideways. Okay, so the first step with implicit differentiation is take the derivative with respect to x to each side, which is notated as d dx. That's an operator. We're going to take the derivative with respect to x of the left-hand side, and that's going to equal the derivative of the right-hand side. So we took the derivative of each side. So I wrote note. We're going to need the chain rule for the left-hand side, LHS left-hand side. So let's take the derivative of this left-hand side. Do you remember the chain rule? Boom, you bring down that exponent of 3, you keep the base as it appears, and then you decrease the power by 1. So 3 minus 1 is the 2. And then by the chain rule, you got to go times the derivative of the inside part. So the inside part is a bunch of terms, 3 terms. So what's the derivative of x with respect to x? 1. Minus, what's the derivative of y with respect to x? Just write dy dx. Or you can write y prime. They mean exactly the same thing, whatever you like. So I wrote dy dx, but you could have written y prime. And that's going to equal 1, because when you look at this, when we took the derivative of each side, for the right-hand side, what's the derivative of x with respect to x? And the answer is 1. Okay, note. We want to solve for dy dx because that will be what the derivative is. So the whole key is to solve for dy dx whenever you want to find the derivative. And we're going to first divide. So let me just show you this equation again. We have this equation right here. I want to solve eventually for this dy dx. So let's get this factor by itself by dividing both sides by this right here, 3 times that whole thing squared. So when I divide each side by these 2 factors, the left-hand side is just going to be the 1 minus dy dx. Since it's not being multiplied by anything, I don't need parentheses. And that's going to equal 1 over these 2 factors. Okay, what do you think I'm going to do next? How about subtract 1 to each side? Because I want dy dx by itself, so get rid of this positive 1. So subtracting 1 to each side, let me just show you what I have here. Subtract 1 from each side. Okay, so when I subtract 1 from each side, here's what we get. Negative dy dx equals 1 over 3 times x minus y minus 1 squared, and then minus the 1. But I want dy dx, not negative dy dx, so change all the signs. multiply both sides of the equation by -1, which means every sign changes. So now I get this. dy dx equals, originally this fraction was positive, but when I multiply through by negative, it's a negative. Here it was a -1, but minus a minus is a plus. So this is the derivative right here. dy dx is by itself. This will tell me the slope of the tangent line to any point on the graph of that equation, for any point. So this is the slope of the tangent line at any point x comma y. But we don't want any point. We want this point at 1, -1. 1, -1 is on the graph of this equation. Because notice, if I let x equal 1 and y be -1, this is going to be 1 minus a -1, which is 2, minus 1 is 1, 1 cubed is still 1, and 1 does equal 1. So that means since it solves the equation, it's a point on the graph. So we want to find the slope of the tangent line to that graph at this particular point. So let's see where I am here. Here's where we are. This will tell me the slope of the tangent line for any xy. So for the next step, here's what you can notate. You can write the derivative evaluated at 1, -1. X is 1, y is -1 is equal to. So this is what we really want to know. What is the slope of the tangent line at this point on the graph? So wherever you see an x in your dy dx answer, you're going to write 1. Wherever you see a y, you're going to write a -1 because all points are x comma y. So notice here, I wrote a 1 because x is 1. And then minus y. Since y is a -1, what's minus a -1? Plus 1. That's why I wrote plus 1 there. And then you got that -1, and then it's all squared plus 1. So I made my substitutions. So I'm evaluating the derivative at the point x is 1, y is -1. So from the line above, wherever you see x's, you write 1s. Wherever you see y's, you write -1s. But minus y, when y is a -1, simplifies to plus 1. Okay, and then just simplify this. So this is going to be a -1 over 3 times 1. Because 1 plus 1 is 2, 2 minus 1 is 1, and then 1 squared is still 1. So that's where that 1 came from. And then this is just going to be -1/3 plus 1. And what's -1/3 plus 1? A positive 2/3. So that is the slope of the tangent line at that point, 1, -1. And now that we have a point and a slope on that line, we can write the equation. So here we go for our final answer. And finally, the equation can be written in the form y equals mx plus b. That's slope-intercept form. Some of you might prefer the point-slope form, so do it that way. It's up to you. Okay, and if you like the way I'm doing it, we have to find b. The only way to find b is if you fill in for x, m, and y. So our point xy, we know y is -1. M, we just found, slope is m. That's 2/3. We just found that out. X was given as 1, because our point is 1, -1, plus b. This is my only unknown. So if you subtract 2/3 from each side, you're going to get b as a -1 minus 2/3. Since they're both negative, you can write it as a mixed number that's negative. And then I converted it to an improper fraction. You just go 3 times 1 is 3, plus the numerator 2 is 5. Keep the denominator the same. 5/3 negative, because it was negative there. So now that I have my b, I'm 98% done. So here's the final answer. Now we know b. The equation of the tangent line is y equals 2/3 x minus 5/3. So that is our final answer. All right, hope that helps, and we'll talk to you later. So again, this was a homework problem from section 3.6 on web design. Good night, everyone.